Okay, the next unit in geometry is called two-dimensional measurements and modeling. And this lesson is called circles, and we're going to do area, circumference, sector area, and arc length. And so a few definitions to start. Some of them we talked about previously. First definition is called the perimeter. The perimeter of a figure is the sum of the side lengths of the figure. Perimeter. The next definition is the area. The area of a figure is the number of non-overlapping square units of a given size that exactly cover the figure. That's going to be the main thing that we do in this entire unit, area. This next sentence is important, okay? Perimeter is always expressed in linear units such as inches or meters, and area is expressed in square units such as square centimeters, square inches, square feet, and so on. Now, this entire lesson is going to be about circles. So this next paragraph talks about circles. Some of it we talked about in the last unit. In a circle, a diameter is a segment that passes through the center of a circle and whose endpoints are on the circle. Okay, we did that in the last unit. A radius of a circle is a segment whose endpoints are the center of the circle and a point on the circle. And the circumference of a circle is the distance around the circle. Think of that as basically being the perimeter of a circle. Okay, so we have two formulas for right now. There's circumference, which is labeled with a capital C. The circumference of a circle is given by the formula circumference equals pi times diameter, or circumference equals 2 times pi times the radius, because 2 times the radius is the diameter. So you can use either one of those equations to find the circumference of a circle. And the area, which is labeled with a capital A of a circle, is given by the formula area equals pi times the radius squared. Okay, so example 1, find the circumference and the area of a circle with a radius of 5 inches. And it says, give your answers in terms of pi and as a decimal, round to the nearest tenth. Okay, so there's two parts to this question. Let's do the circumference first. Circumference. Now we have two formulas for circumference above. We can use either one, but we're given the radius, so we're going to use the formula with the radius in it. So circumference equals 2 times pi times radius. We know the radius is 5, so we're going to substitute 5 in for the radius. 2 times pi times 5. It says give your answers in terms of pi and as a decimal. So when it says in terms of pi, you're going to leave the pi in the answer, and you're going to multiply everything else together. So 2 times 5 is 10. So circumference equals 10 pi. And the units are just going to be inches. Not inches squared, just inches. So that's the answer in terms of pi. And then it says as a decimal, rounded to the nearest tenth. That means 1 decimal point. So do 10 times pi, and you'll get the circumference is approximately 31.4 inches. Those are the two answers, in terms of pi and as a decimal. And now let's do the area. Okay? Area equals pi times radius squared. So area equals pi times the radius is 5. So pi times 5 squared. Same directions. Give your answer in terms of pi and as a decimal. So 5 squared is 25. So you're going to say area equals 25 pi. And it's going to be inches squared because area is always in squared units. So that's one answer. And then multiply 25 times pi to get the decimal. Area is approximately 78.5 inches squared. Okay. So that's example 1. I have 7 examples here. Okay. Example 2. Almost the same thing. This time you're given a diagram though. Find the circumference and the area of the circle below. Give your answers in terms of pi and as a decimal rounded to the nearest tenth. But the only thing you have to be careful for is you're given the diameter. The diameter equals 8 centimeters. Let me just label that. The diameter equals 8 centimeters. That means the radius is going to equal half of that. So 8 divided by 2 gives you the radius is 4 centimeters. Okay, be careful for that. And now we'll just go into each formula, just like we did in example 1. So I'll go a little faster this time. Circumference. We can use either one of the equations on the previous page. I'll just go with 2 times pi times radius again. It's going to give you 8 pi. And again, the units are centimeters, not centimeters squared, just centimeters for circumference. Then multiply that out, you get 25.1. Okay, remember, it wants the answer 2 ways, so we have to put it both ways. With pi, and then as a decimal. Now let's do the area. Area equals pi times radius squared. So pi times 4 for the radius, 4 squared. 16 pi. And remember, area is squared unit, so 16 pi centimeters squared, because you're multiplying 4 centimeters times 4 centimeters. That's why it's centimeters squared. And as a decimal, approximately 50.3. All right, so that's examples 1 and 2. Example 3 is going to be a working backwards problem. Find the radius of a circle given the circumference is approximately 35 millimeters. Round to the nearest tenth. So since I have circumference and I'm asked for the radius, I'm just going to copy down the circumference formula with the radius. Circumference equals 2 times pi times radius. Okay, copy down the formula first, and then substitute for what you know. You know the circumference is 35, so substitute 35 in for C. And we're going to solve for the radius, R. So if you're going to solve for radius, you're going to divide by 2 pi. So 35 divided by 2 pi is going to equal the radius. But you have to be careful for how you type this in your calculator, okay? You want to put the 2 pi in parentheses. So I'll show you on mine. 35 divided by, and put the 2 pi in parentheses. Okay. I'll give you approximately 5.6 because it's the nearest tenth. Okay. If you don't have a calculator that's able to use parentheses on, then what you're going to have to do is you're going to have to do 2 times pi first, and then get that answer, and then do 35 divided by that answer. So the answer is 5.6. And radius is in millimeters, not millimeters squared, just millimeters. Okay. All right, so this next example is another working backwards problem, but this time it deals with the area. So let me copy down the area formula first. Area equals pi times radius squared. We know the area is 154, so we're going to substitute 154 in for the area. We're going to solve for the radius. So what we're going to do now is we're going to divide each side by pi. 154 divided by pi equals the radius squared. So you're going to type that in your calculator. And what I'm going to do is I'm going to write out all the decimal points for now. So I'm going to say I'll round in my final answer. So when I do that, I get 49.0197. 2247. I'm going to round at the end, not yet. Now, think back to Algebra 1. You have the radius squared equals 49.01972247. To solve for the radius, what you're going to do is you're going to take the square root. Okay? The square root of 49.01972247 equals the radius. Now, in Algebra 1, when you did that, you would take the positive and negative square root. But since we're doing a distance, we only want the positive one. So the square root of 49.01972247, when you type that in your calculator, you're going to get approximately 7.0. It said nearest tenth. So I'll say approximately 7.0, and that's going to be in inches. Okay. So we have 4 problems down, and we have 3 left. Before we move on to the final 3 examples, there's 2 things we have to look at. Okay. First one is called the sector of a circle. Okay. A sector of a circle, you can think of it as being like part of a circle. If you think of a circle as like being like a pizza, like a sector would be 1 piece of pizza, or 2 pieces of pizza, or 3 pieces, and so on. Okay. A sector of a circle is a region bounded by 2 radii of the circle and their intercepted arc. So if you look at this diagram, this is called a sector. The part that's shaded in, that's a sector. We have to find the area of a sector. So the way you do that is you get the area of the entire circle, pi times the radius squared, we just did that. And then you multiply by just the portion you want over 360, because 360 is the entire circle. Okay? So we do pi times the radius squared times the measure of the arc over 360. We'll do an example on that in a minute. Okay, that's a sector. The other thing we're going to talk about before we do the final 3 examples is called arc length. The arc length is the distance along an arc. Okay, so the distance of an arc. Think of it as being part of the circumference of a circle. So if it's part of the circumference, and you want to know the length of this arc, you just do 2 times pi times the radius, that's the entire circumference, times the measure of the arc you want over 360. Okay. I know that can be a little wordy, so let's get to some examples where we go over that. Number 5, find the area of sector ABC. Give your answer in terms of pi and as a decimal. So just real quick, the central angle is 90. That means that this arc is 90, because central angles equal the arcs they intercept. Okay. So here we go. I'll do A for area again. It's going to equal the area of the sector is going to equal pi times radius squared. And that's going to give you the area of the entire circle. We don't want the entire circle. We want just the sector that's shaded in. So I'm going to say times the measure of the arc over 360. So I'll say measure of arc AB over 360. All right, let's substitute and let's solve. Pi times 1 squared, because the radius is 1, times the measure of arc AB, which is 90, over 360. All right, so again, I'm asking you for the answer in two different ways, in terms of pi and as a decimal. Okay, so when I say in terms of pi, that means you're going to multiply everything but the pi. Okay, so you're going to do 1 squared times 90 divided by 360. Okay, 1 squared times 90 divided by 360. That's going to give you 0.25 pi. So that's one answer. The units are going to be meters squared because we're doing area. And then I asked for the answer as a decimal. It doesn't tell you where to round, so you can round however you'd like. You're going to do 0.25 times pi. I'll say approximately 0.79. Does not tell you where to round for this problem. So I'll do 0.79 meters squared. So again, you just get the area of the entire circle times just the portion you want. So you take that arc, which was 90 in this example, and you do 90 divided by 360. Okay, two more examples. Example 6, find the length of arc AB. Give you answer in terms of pi and as a decimal. You want to use the formula from the previous page. Again, before I even start, that's 45 degrees for the central angle, which means that this arc is also 45 degrees. That's the measure of the arc, not the length of the arc. We're going to get the length of the arc, but the measure is 45. So here's our formula. We're going to use capital L for arc length. And this is the formula from the previous page. 2 times pi times radius times the measure of arc AB over 360. Okay, now let's substitute and let's solve. So 2 times pi times the radius of 12 times the measure of arc AB, which is 45, divided by 360. All right, so again, this wants our answer two ways, in terms of pi and as a decimal. So in terms of pi, you're going to multiply everything but the pi. So you're going to multiply 2 times 12 times 45 divided by 360. That's going to give you an answer of 3 pi. There's no units labeled for this one, so I'm just going to say 3 pi units. That's the arc length. And then as a decimal, do 3 times pi, and you get 9.4. Again, it does not tell you where to round, so I'll just say 9.4 units. Remember, arc length is like circumference. It's part of the circumference, so just the units, just like units or centimeters or meters. They're not squared. That's area. Okay, so one final problem. Find the area of the shaded segments below. Okay, this is called a segment of a circle. Okay, it's the space between a chord and the arc. Okay, so this shaded thing, that's called a segment of a circle. So how are we going to solve for that? How are we going to get that area? What we're going to do is we're going to get the area of the entire sector and then subtract out the area of the triangle, and that will give us the area of the shaded segment, okay? So I'll write that down. We're going to do area of sector GHJ minus area of triangle GHJ. That's how we're going to do it. This is the hardest one on here. That's how we're going to do it. We're going to get the area of sector GHJ and then subtract out the area of triangle GHJ. So let's do the sector over here. Area equals pi times radius squared. So pi times 14 squared times the central angle is 90, which means that this arc is also 90. I'm going to do times 90 over 360. $14 squared is 196 times 90 divided by 360. It's going to give you 49 pi. Now let's do the area of triangle GHJ, and then we'll subtract those two to get the final answer. So area of triangle GHJ. In case you forgot, the area of a triangle formula is area equals 1/2 times base times height. The base is any side of the triangle, and the height must be perpendicular to that. So, do you know, can you figure out what GH is? It's not labeled, but can you figure that out? You should be able to figure that out because every radius is congruent in a circle. So if this radius is 14, then this radius also has to be 14. So for my formula for the area of triangle GHJ, I'm going to do 1/2 times 14 times 14. It's going to be 98. Okay, and now the final answer. Let's get the area of the segment because that was the question. I'll say area of shaded segment. We're going to subtract the two answers we just got. So we have 49 pi minus 98. Type that in your calculator. And you can round to wherever you want to because it does not specify. I'm going to say area is approximately 55.9 meters squared. Okay. So our last unit was on circles. This entire lesson today was on circles. I included it in Unit 9 because this unit is all about area. That's what most of this was about. And that's the end of that lesson.